Hello, General Biology, and welcome to the third screencast in our Chapter 6 series, Humans in the Biosphere. And we're still talking about Section 6.2, so this will be the second video for Section 6.2. And we were talking about water and how water is considered a renewable resource, but some of our sources of storage are non-renewable. And one of the things that we need to be concerned about is water pollution. And we have to understand what a pollutant is. And a pollutant is something that is harmful in some way: chemical, oil, soap, even Coca-Cola. I mean, I know there's things that we drink and we eat and we put into our own systems, but Coca-Cola and Pepsi, you can put on your car and it'll eat through the paint finish of your car. That's how harmful it is. And sometimes, we just spill it into the grass. We dump our excess into the grass if we're outside. And that's a pollutant. That's a harmful material. And we have different kinds of pollutants that we have to consider with water. One is a point source pollution. And a point source pollution comes from a single source, like an oil spill. And several years ago we saw a big oil spill happen in the Gulf Coast with BP oil, where millions of gallons of oil spewed out into the Gulf Coast. That would be considered a point source pollution. A non-point source pollution, which would come from smaller sources, these are things that you probably don't even think of. Oil that's washed off the streets from the rain, chemicals that are released from the air from your factories or from your cars or from heating your homes. And those are non-point source pollutions. Whatever the source is, when it gets into the water, it changes the chemistry of the water, which impacts the lives that live and depend on that fresh water, whether it's salt water or fresh water. And it also impacts how those habitats are able to function. So when we consider, well, what's the primary source of water pollution? Most of it is industrial, making all of those wonderful products that you enjoy, maybe the chair that you're sitting in as you're watching this on your computer, making your computer, a television set, the way that you heat your home. All of those come from industrial. Agricultural chemicals, the fertilizers that we use in order to make our crops grow more productively, the pesticides that we use to stop nuisance pests from damaging those crops. Residential sewage is another. Every time you flush that toilet or take a shower or run your dishwasher or your washing machine, you're putting sewage out, and that needs to be converted so that it's back into a clean water source. And non-point sources. Let's take a look at this video. So let's go back, and I challenged you in the beginning of this chapter to think globally. What could you do? You just saw some ideas that a lot of people think, well, just because I make a change doesn't mean it'll have an impact. Yes, it does. Every little change is important, and it does make a difference. So I challenge you again in this screencast, stop using plastic water bottles. I know a lot of you have the swells, and you have other kinds of water bottles. Let's see more use of those water bottles. Consider what you're dumping when you're dumping. Start locally. That little local impact can have a global effect. And let's start protecting Earth and the resources. Okay, one of the things that I want to talk about is something that scientists refer to as biological magnification. And in the video, you noticed, hopefully you saw that when we put plastics into the ocean, and these are plastic bags, plastic water bags, the plastic little rings that hold our bottles together, our soda bottles together, that takes thousands of years and sometimes never, depending on the grade of plastic, to degrade, to break down. And some of these plastics leach out chemicals, and you just heard me use the word leach. That means kind of like leaking out, seeping out chemicals. And one of those chemicals you've heard of in the news in recent years, BPA, which was found in a lot of plastics that they're finding actually can cause birth defects and brain damage and cancer and all sorts of things like that. So they've removed BPA from a lot of our plastic products, but some products still contain it, and if they're put in dumps, then this leaches out, and it can be absorbed into plants. It can go into our water systems, and then when organisms eat that, it goes into the organisms at higher levels. We call this process biological magnification. And what we can see here in this picture is an example of biological magnification. Back in the 1960s, a chemical called DDT was used as a pesticide on farms and to get rid of mosquito populations. We noticed that the eagle population, the numbers of eagles and a lot of the bigger birds like the hawks were starting to go down. They were starting to drop. So as scientists looked into what was happening, they discovered that the eggs of these birds were developing very, very thin shells, so that when they were laid, they would either break, or they were susceptible to bacteria, or when the mother sat on them to keep them warm, they would crack. So very few eggs were making it to develop more birds, more of these fish-eating birds. So they were trying to figure out the cause, what happened, and they discovered that in the water from runoff was high concentrations of this DDT that the farmers and communities were using as a pesticide. And what happens is the producers, like phytoplankton and algae, were absorbing this DDT into their tissues, so that when the zooplankton, which are tiny microscopic animal-like organisms that ate the producers, they were getting an increase in the toxic amounts of this DDT. And you can see this by the numbers as they go up here. So when small fish ate the zooplankton, if they ate 10 zooplankton, they're getting 10 times more the amount of toxic DDT into their tissues. And this continued up the food chain. So as large fish ate the small fish, again, 10 times more, we're now up to 1,000,000 times greater the amount of DDT, and by the time it got up to our eagles and our hawks, it was 10 million times the concentration than that in the water. This is biological magnification, and this happens. You saw in one of the videos that we watched that humans are filled with pesticides. 13 different kinds of dominant pesticides that we're filled with, and that's because of where we eat on the food chain, what we do eat. So what causes this? Industry puts different pollutants into our water supply, and so does agriculture. They put different chemicals into our water supply. The chemicals can then be harnessed or trapped in the tissues of the organisms. The primary producers will absorb those chemicals. Then the herbivores that eat the producers, they'll consume more of the chemicals and absorb more. The carnivores will eat the herbivores, and the chemical toxins increase in the tissues of the carnivores. So the higher up the food chain, the more toxic the substance becomes as it collects in the tissues. So when we consider water pollution, soil pollution, these are the things that we need to take into account. Mercury is another good example. Mercury getting in the tissues of fish and people eating mercury, and mercury causes, again, birth defects, cancer, mental impairments, problems like that. All right, we're going to end this here a little bit short, and we'll take a look at water and sustainability in the next screencast.